Hi, in this video I'm going to introduce another concept of random variable, okay, and it's a continuous random variable. For example, okay, given a function, right, given a functions, so which is defined by this in the piecewise form, and it's required to show that x, okay, x, this function is represent that x is a continuous random variable with probability density function fx. They also show that x is a continuous random variable with a probability density function fx. So how to show that this is a continuous random variable and with this is a probability density function, all right? So you must know that the integration for all the area, okay, for all the interval, okay, or with this is the meaning of all, right? When we integrate, okay, so is from for fx, right? For fx, dx must be equals to 1, right? Must be equals to 1. So if we able to show that the integration means that the integrate of all the value of x in the interval defined by this probability density function is equals to 1, then it's already show that x is actually an continuous random variable with this probability density function, all right? So let's see. Okay, the meaning here very simple here. So I try to integrate. Okay, the meaning here, if I integrate everything, here, it actually means that I integrate 0 to 1, right? 0 to 1. So for x over 2 dx plus with from 3 to 6, right? All the interval, right? 3 to 6. So 3 to 6, which defined by the function x over 6 dx, all right? And the rest that are not in this interval, the value of x which is not in this interval, all is considered to be 0, right? 0. So means that the probability density is 0. So now, okay, let's start integrating this and show, right? We have to show that the area or the total, the sum, okay, the integrate of all the interval for the probability density is 1. If we're able to show that this is equal to 1, then this is definitely the probability density function that represent the continuous random variable. So okay, let's integrate this. So integrate, you have x power of 2 over with 2 times 2, 4, right? 4. And where else? From 0 up to 1. And integrating 1, you are having x. Integrating x, you adding 1, power of 2, divided by 2, means that 6 multiplied 2, you have 12. This one is from 3 up to 6. Alright, 3 up to 6. So, very simple. We're going to evaluate it as usual. So, 1 square over 4 minus with 0, right? Because it substitutes 0, 0 power of 2 over 4 is 0. So, plus with 6. 6 minus with 6 power of 2 over 12. Minus away 3 minus 3 square over 12. So from here we were getting 1 over 4, right? 1 over 4, and let's calculate this. From here we have 6 minus with 36. 36 over 12, we have 6 minus with 3, minus with 3 minus 9 over 12, right? 9 over 12. Okay, let's evaluate this part here, which giving the whole thing here to be 3 over 4. Okay, this will be 1 over 4, and this whole thing here after evaluate will be 3 over 4. So total up, you are getting an 1, right? You are getting 1. So means that you integrate for all the interval for this fx, right? The value that you get is 1, right? When you get the value is 1, this have already shown that this is a continuous random variable with this probability density function, alright? As simple as that. I have already showed that integrate of all the interval is 1. Alright, okay, just now we have already integrate for all the interval. We evaluate, okay, the most proper word will be we evaluate the integral for all the interval that given, alright, from 0 to 1, integral from 3 to 6 for this. We are getting the value of 1, right? If I show that this is a continuous random variable, this is the probability density function for the for continuous random variable. So now how to using this probability density function to sketching the graph. Alright, I'm going to introduce you how to sketch the graph for a probability density function. It's just like you sketching a piecewise function, right? So at first sketching the axis, right? Sketching the axis, so you have x, y, 0, alright? So usually we just look at the positive, alright? As the probability density function must be positive, alright? It must be positive because it represents the probability, right? Fx itself must be at least 0, alright? Means that it must be in the first quadrant, or we can just write y equals to fx, okay? It must be in the first quadrant, as probability density function must be positive, alright? So, and 0 up to 1, right? During 0 to 1, so it was a straight line, right? It was a straight line. So we just using these 2 points, right? We need 2 points to sketch a straight line. So when you put 0, right? Substitute 0. 0 over 2, you are getting 0, right? So means it start with 0, and at origin, if you put 1, 1 over 2, right? So you have 1 over 2, 1 over 2, and you draw a line, right? You draw a line. So means that from 0 to 1, the function here, the fx here, is referred to x over 2, right? Is referred to x over 2. Okay, now followed by 2, 3, so 4, 5, and 6, right? So 4, 5, and 6. So it's from 3 up to 6. There is no probability density function for 1 to 3, all right? For 1 to 3, it's otherwise 0, right? The probability density function is 0. So 3. So this is also a straight line, right? It's a straight line. So you put 3, right? Put 3. You substitute 3, right? Substitute 3. 1 minus 3 over 6. 1 over 2, right? So during 3, it will also be 1 over 2. Right? Okay, later on, when you substitute 6, 6 over 6, 1. 1 minus 1, 0. Right? So this is the graph of the probability density function. Right? I want to explain. Actually, this graph, the area under the graph must be equals to 1. Just now we have already verified that. We have verified that the integral, okay, the value of the integral for all the interval, right? If I evaluate the integral from 0 to 1, and the value of integral for 3 to 6, if I add up the value, it must be equals to 1. This is the meaning here, the negative infinity to positive infinity. It means that if we evaluate the integral for all the given interval for a function is equals to 1, then this is a probability density function. Okay, I repeat again. So that's why if you calculate the area for this, right? How to calculate this area? This is a triangle, right? For your knowledge, alright, this is for your knowledge, half times with the base 1. The height will be 1 over 2. So you are getting 1 over 4, right? Just now you integrate from 0 to 1, you are actually getting 1 over 4. And definitely here will be give you 3 over 4, you see? 1 over 2. 1, 2, 3, right? 6 minus 3, the length is 3. The height is 1 over 2, right? So you're getting 3 over 4. So if you add up 3 over 4 and 1 over 4, you will find out that the area under the graph actually is not only for this function. It's for all the probability density function, all the probability density function for continuous random variable. The area under the graph will be always equals to 1. Alright, that is further to tell you that the meaning of probability density function. Okay, and how to using the probability density function in finding a probability. Okay. Alright, okay, let's see if the question is asking you to find the probability, right? Asking you to find the probability between 0 and 4, right? Probability between 0 and 4, for example, is between 0 and 4, right? The probability from 0 up to 4, and you must know that now this is a continuous random variable. X is a continuous random variable. So from 0 up to 4, so it's actually, if you look at the function here, you should integrate 0 up to 4, but there is 0 up to 1, right? 0 up to 1. So first is from 0 up to 1. It's defined by this function, right? It's defined by this function, so we need to write x over 2 dx, right? After 1, the function is different, right? It's different. So you must remember that from 1 up to 3, there is no function, right? No function means that, you see, from 1 up to 3, the fx is 0, right? The fx is 0. This is otherwise, right? Otherwise. But start from 3 to 6, there is a function, right? But we just need up to 4, right? Up to 4. So plus with 3 up to 4, right? You see 0 to 4, right? It's between 0 to 4. But from 0 to 1, the function is x over 2, right? And 3 to 4, right? The 3 to 4 is within this interval, right? 3 to 4 is within this interval, 3 to 4. So, and from 1 to 3, right? 1 to 3, if you look at the line here, you have 0 up to 1, right? 1, 2, 3, 4, right? So from 0 up to 1, the function is x over 2, right? And from 1 up to 4, right? From 1 up to 4, only 1 up to 4, only 3 up to 4, right? 3 and above, we have this function, right? 3 up to 4, 3 up to 6, this is belong to the function of 1 minus x over 6, right? 1 minus x over 6. And for this, is belong to x over 2, right? From 1 up to 3, there is the function is 0, right? The probability density function is 0. So now from 3 up to 4, the function is 1 minus x over 6 dx. Or you can actually refer to this graph here, very simple. So from 0 up to 1 and 3 up to 4. 3 up to 4 is actually talking about this area. If you can perform finding the area by using the concept of triangle and trapezium, you also will get the same answer here. So, and you will have x power of 2 over with 4 from 0 up to 1. This definitely will be 0, okay? Will be 0. So for this, you will have x minus with x to the power of 2 over with 12 from 3 up to 4. Alright? Alright, after you evaluate, you substitute the 1 minus with the 0 over 4, and you substitute the value of 4 upper limits minus the lower limits, then you were getting 1 over 4, and for this you were getting 5 over 12, right? If you're adding up the probability with 1 over 4 plus with 5 over 12, you are getting 2 over 3. Alright, the probability from 0 up to 4, right, is from 0 up to 4 is 2 over 3, right? So it's actually the same thing as if you calculate the area here, right? So means that is from 0 up to 1, okay, 0 up to 1 and 3 up to 4, right? 3 up to 4. So means that if you find the area from 0 up to 4, right? 0 up to 4, so this is the area. So the total up of this area and this area will be getting 2 over 3. Alright? That's the probability, okay? Its probability is actually the area under the graph for the probability density function. Alright? Okay, let's look at another examples. Alright, okay, how about the question asking us to find the probability of x greater or equal 5, right? So, very simple. Okay, as we know that we have 0 to 1 and 3 to 6, right? Okay, so we'll just draw here 0 to 1, 2, 3, 4, 5, up to 6, right? So from 0 up to 1, right? 0 up to 1, the function here, from 0 up to 1, the function here is fx is x over 2, right? And from 3 up to 6, from 3 up to 6, but there, here the fx is 0, right? Fx is 0, so not defined for 1 to 3. So 3 up to 6, the fx will be 1 minus x over 6, right? Within 3 and 6. So now, I want the probability from x greater or equal 5. Which one is meant by greater, left or right? Definitely is right, right? So this is the region, right? It's a region. So means that the one that on the right, okay? More than 5 means from 5 up to 6. Because from here, it's up to 6, there is a function. After that, there are no function, right? So 5 up to 6. So even though they said greater or equal 5, we are integrating from 5 up to 6, right? 5 up to 6. So 5 up to 6, which is using this interval, the function for this interval, which is 1 minus x over 6 dx. All right? Then we just evaluate. So you integrate the x, right? 1, we're getting x. For this, we have x squared over 12, right? So then, if you evaluate this, then you will get the probability for x more or equal 5. Okay, very simple. Okay, 6 minus with 6 squared over 12 minus with 5, right? 5 minus 5 squared over 12. So if we evaluate the probability, if we evaluate the integral here, the value that you get will be the probability for x greater or equal 5. Then we are getting 1 over 12, right? 1 over 12 is the probability for x greater or equal 5. All right, that's all for this video.